Welcome back again, guys. Now we will discuss uh, 9 categories of problems. In this, there are three. Let's say one is permutation. Permutation has 3 categories: permutation with no repetition, no repetition, with permutation with limited repetition, permutation with unlimited repetition. Guys, this is one type, two type, and three type. Alright. Next is combination. One is no repetition. Second is limited repetition. Third is unlimited repetition. Right. These are these 4, 5, and 6. Number 7, 8, and 9 are three different. Let's say number 7 is distribution problem. Number 8 is principle of inclusion and exclusion. Ninth is pigeonhole principle. These 9 types of categories of problems and combinatorics, and we will discuss one by one of all of them. So first, for short notes, we will write some formulas for this. This is NPR, where R is less than or equal to N, and in limited representation, N factorial upon N1 factorial, N2 factorial, N3 factorial, and so on. And for unlimited repetition, N to the power R, right? And for combination, NCR for no repetition. For limited repetition, we use generating functions, right? And for unlimited repetition, we will use N minus 1 plus R CR. These formulas are short. We will discuss them in further lectures. And one note here is in order to arrange noted. This is noted in the note here. No. So one note here is this. We can write this note. Right. For permutation, some keywords are like, we can say uh, numbers are there, letters, words, right? And arrange, boxes. These are permutation keyword. And for combination, where order does not matter, keywords are set, subset, right? And these are type of uh, we can say data sets. The order does not matter. And some selecting people, selecting things from the object, and collect. We can say team also is part of combination. Committee. These keywords are for used for combination. Alright. So now we will discuss some examples and let's go. So one first example is these are 5 letters, letter words from 26 letters of English. Alright. So how many ways we can uh, how many words of 5 letters from 26 letters of English we can create without repeating any character. So these are 5 places we can put some values. So first value can accommodate 20 any of there are 26 ways for first. Now then 25 ways for second, 24 ways for third, and 23 for fourth, and 22 ways for fifth position. Alright. We can this is first, this is second, third, fourth, and fifth, and first place. First place we can do this work by 26 ways. Alright. For this we can do is 25, 24, 23, and 22. After doing this, we will do one by one them all of them. Alright. So by multiplication rule we can sum up this like that: 26 factorial upon 21 factorial, which is 26p5. Alright. So to understand this, if there is no repetition, alright, no repetition, if unlimited repetition is allowed, then there are 5 places. We can do this 26 ways. This is also 26. All of places can be filled by 26 ways. So we can multiply this, and answer would be 26 to power 5, which is n to the power r. Alright. So one note is by default words repeats letters if not mentioned. By default words repeats letters if not mentioned. So by default words will repeat itself. Right? Word will repeat letters. It is not mentioned specifically. Right? So what we can say is, for question is, 5 letter word start with A and end with G. What we can say, there are 5 places. This is 5. G and A are only one ways, but at these we can put 26. All of the picture goes. It can repeat also. It will be like 2 to the power 3. On that, yeah, we do it. but if repetition is not allowed, then it would be like this: A, Z, 24 here, 23 here, and 22 places are allowed here. Alright, so it would be like uh, n minus 2 PR. Alright, something like that. Next is next question is 5-letter word. Let us start with A or B and ends with C only, and repetition is allowed. So how can we do this? 2, 3, 4, 5 places are there. A or B, there are two possible ways, alright. 26 here, 26 here, and 26 possible ways here. And C only one way here. So 2 and 2, 26 to power 3 is the answer. Right. Next question is 5-letter word, right? And which start with vowel and ends with G. Alright. Repetition not allowed. So what we can do is 1, 2, 3, 4, 5. And 5-letter words to start with vowel and start with vowel. So these are 5 possible ways: A, E, I, O, and U here. 5 possible ways here. Alright. One of them will choose. And remaining is 25. Alright. No repetition is allowed. And one CH, G is here. Alright. Ends with G. Then what we get, repetition is not allowed. So it can accommodate what? Or 24 here, 23 and 22. Right? Because this is only G here and this is only one way. So it would be like 5 into 20. 4 into 23 into 22 is the answer. Right. Next question, we will change the color of pen here. Green it would be good. From question is from 10% arrange 4 in 4 chairs. Arrange 4 in 4 chairs. How many ways? So these are 4 chairs: 1, 2, 3, and 4. Right? 10 persons are there. We can accommodate 10 here, 9 here, 9 ways, 8 here, and 7 here. Right? And it would be like this. Right? This would be 10p4. Alright. Small value. If it is 10 chairs and 4 persons, then it would, answer would be the same, 10p4. But here is now person and there is chairs. Alright. This is not a big game. So because by default person does not repeat themselves. Alright, this is the question answer. Next question is 10 people. Alright, arrange 4 where 1 always gets selected. Arrange 4 where 1 always gets selected. Alright, so there are 4 chairs here. Alright, one person always gets selected, so it can choose any of the chairs, so it is 4 ways. And and is 9, 9, 8, 7 and 6. Alright, alright, so no, this is not how we do it. We can do this, but not like this, right? So it would be like uh, select 3 people from 9. It would be like 9C3 and arrange 4 and 4 chairs, right? It would be like 4 factorial. 4 into 3 into 2 into 1, like that. So how can we do this? Alright, and next is 3 to 1, 3 to 1, 4, 4, and this 4 into 9 c 3 into 3 factorial, 4 factorial only. And we can do this. Alright, so 9p3, 9c3, 3 factorial, 4, 3 to 1, 1a, a 3, 4, 4 ways, 4 into, and what we can do, if 2 always gets selected, so what we can do is 8c4 into 4 factorial, like that arrangement. And second thing is 8p2 into 3 and 4 xy, let's a 1 2 3 3 times 3 ways, and now this in 4 ways, right? Right, so this is can do this also. Next is note here, NPR and NCR is n is greater than R, is equal to R, right? So note one more, 10 chairs 4 persons, it would be n is 10, r is 4, which is person. Alright, if 10 person and 4 chair, same, n is person and r is chair. Okay? But answer would be the same. Make boxes of which is smaller. Yes. Make boxes or spaces which is smaller. Right. Next would be like this. Question is like, question is, there are two teams, A and B, right? 10 games, tournament, right? Then outcome of each game is A won or B won or tie, right? The total number of outcomes of entire tour. Total number of outcomes of entire tournament. So there are 10 tournaments, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 10 matches, 10 games. So first game has three possible outcomes, 3 and so on. So 3 to the power 10 is the answer. Alright. And next is, if first and third game wins by A, then there will be 3 to power 8, because this is first and third game only one possible outcome. First game has possible outcomes only wins A or B and 2. Alright, this is not very hard. The question number next would be 10 dices are thrown. How many outcomes? 6 into 6 into 6 divided 6 to power 10 is the outcomes. Alright. Some note is also here that this is good. Right. Some note here is here in this case, here by default we assume each dice is distinct, not identical. Alright, is that if two dice thrown, then 5 and 3 outcomes is not equal to 3 or 5 outcomes. But if identical 5 and 3 outcomes will be same as 4 and 5 outcomes, order does not matter here in identical dices. Alright, so all are different dices. This is not radical dice. Yeah, it's correct. If this is a dice, alright, and this is also dice, same dice. But if it is dice and this is one dice, outcome are different here, alright. But in this come one or this come one. It does not matter. One, two, three. Yes, this is correct. So dices are distinct here. Alright, guys, we will meet you in the next lecture. Topic would be dice thrown. Thank you so much for watching the video.